Hello, my name is Michael Petryshyn, and the presentation topic I chose to talk about today will be on life in our universe, because people often assume that we are the only ones here in our universe. In reality, the odds of other life existing out there are pretty high. And so that pretty much presents the question, are we alone? And what are the real estimates of life in our universe? And, if life's out there, is it intelligent life? And if so, why haven't we come in contact with any of this life? These will be basically the things I'll be talking about in my presentation. And of course, I'll try to do my best to visually show my points along with my narration. So, with that all being said, I hope you enjoy this. Alright, well, we can't ask the question, is there life in the universe, and not talk about Fermi paradox. So basically what Fermi paradox is, it's the contradiction between, lack of evidence that there is life in the universe to the high probability that it exists. And what's really interesting is that, we can look up on the sky at the very best night and we can see about 2,500 stars, which is roughly 1/100 millionth of stars in our galaxy. And pretty much all of them that we see are less than 1,000 light years away from us. So what we're looking at is this. We're confronted, or when confronted with the topic of stars and galaxy, a question that tantalizes us, most humans that is there intelligent life out there? So, well, let's put some numbers to it. So, for every star in a galaxy, there's a galaxy out there in the universe. So basically, for every star in the colossal Milky Way, there's a whole galaxy out there. This means that for every grain of sand on Earth, there are 10,000 stars out there. Just to put that in perspective. The science world isn't really in total agreement about what percentage of these stars are sun-like, meaning, same size, temperature, etc. Opinions typically range between 5 and 20% of them are sun-like. So going with the most conservative side, 5%, and the lower amount for the total number of stars for our estimate, that gives us about 500 quintillion or 500 billion sun-like stars. So the chances that an Earth-like planet is orbiting a sun-like star is about 22%, which gives us a total of about 100 billion Earth-like planets. So basically, there are 100 Earth-like planets for every grain of sand in the world. Now, let's imagine that on 1% of those planets, the life advances to an intelligent level like it did here on Earth. That would mean that there are 10 quadrillion, or 10 million billion, intelligent civilizations in our observable universe. And according to our Drake equation, there are basically 100,000 or more intelligent civilizations just right here in our galaxy. And we just don't know why we haven't come in contact with them. And just to reiterate here, basically according to the Drake equation, 1 billion Earth-like planets are in our galaxy, as well as 100,000 intelligent civilizations in our galaxy. Now we don't really know if that's true or not, but, in perspective of the Drake equation, that's how it is. And the search for extraterrestrial intelligence has not found any signals, and like I said earlier, we don't know why. And we'll try to put some logic to that in a sec. And things get stranger because where is everyone? There are plenty of sun-like stars out there that are far older than our sun by billions of years, which means they should have Earth-like planets that are billions of years older than ours, which could conclude that there are civilizations out there that are just billions of years ahead of us, far more intelligent. And this brings us to the Kardashev scale, because technology and knowledge of a civilization just merely 1,000 years ahead of us could be as crazy as, comparable to us, like a medieval person or a chimpanzee. So you can't even comprehend what a civilization 1,000,000 years ahead of us would be like, or 1,000,000,000 years. For instance, a planet's X could be 3.4 billion years ahead of us. And depending on the years, that either puts a civilization at type 1, type 2, or type 3. 3 being the most advanced,
So, a Type 1 civilization is a civilization that basically has their ability to use all of their energy on the power on the planet. They're able to harness it and use it to their advantage. We're not quite a Type 1 civilization, obviously, we can't do that. But, we're close, and this guy Carl Sagan created a formula on a scale which pretty much puts us at a Type point 0.7 civilization, you could say. Now, a Type 2 civilization is a civilization that can harness all of their energy on their host star. And our brains can barely even comprehend how they're able to do that and what it would even be like. Now, a Type 3 civilization is the most advanced civilization you could have. A Planet X type scenario where they're 3.4 billion years ahead of us, they'd probably be at the point of basically interstellar travel by then. And most Type 3 civilizations are probably able to colonize galaxies, destroy other civilizations if they wanted to. And the calculations that we have say that there should at least be 1,000 Type 3 civilizations in our galaxy alone. And if they're really truly capable of, harnessing power of stars and interstellar travel, then why haven't we seen any of them yet? This is basically where the Fermi paradox begins. Now, before we go into details about that, this is just a cool little diagram I found that basically explains or visually shows how a Type 3 civilization could colonize a whole galaxy. You got the home planet in the middle, and they launch two ships to two different planets to colonize them. And then each of those planets launches two more ships to colonize another place, and each of those planets launches two more ships. You get it, it's like kind of like the snowflake effect. And within, you see within 5,000 years how many different colonies they have across the galaxy. But it leaves more questions to be asked.
So the simple explanation is that there are no signs of higher life, like Type 2 and Type 3 civilizations, because there just are none. Like we are the first ones to make it past the great filter, per se, the red line that we have crossed already, that no other civilization has crossed. That's a possibility. The next explanation is that we're rare. We have made it past the great filter that barely any civilizations have, but there could be other civilizations that have passed it, and there's still like evolutionary leaps that are hard or rare to make it past that we have to do to get to Type 3 civilization. In this scenario, we are just one of many civilizations that can be on various planets that are just in a transitional phase. We're in between. We got past the great filter, but we're still trying to get to be a higher civilization. It's a astrobiological phase transition. And if we're not rare and we're not early, then that means we're in trouble, because that means the great filter is in our future. And we are about to embark on a journey that many civilizations could have already embarked on and just failed. And there might be one other civilization that's ever gone past it. We just don't know what it's going to be or when. But, it's just an explanation we would have to wait and see. So, just to reiterate for you guys, the Drake equation is a probabilistic argument used to basically estimate the number of life forms out there, possible extraterrestrial civilizations out there in our galaxy. And like I've stated before, it's just a complicated universe out there. We really don't know who could be out there and where, how far away, and what kind of civilizations are there, and where do we place in that? We just don't know. But the Drake equation is basically there to try to put some, logic to the numbers. And all in all, I really hope you guys enjoyed this presentation. I hope you got something good out of it, and I hope you learned basically what the Drake equation is or what the Fermi paradox is. And just a closing statement, is no good news a good thing? This is what Oxford University philosopher Nick Bostrom said. Because if we met aliens, that'd mean the Great Filter is definitely ahead of us, which would ultimately doom us. So like you said, the silence of the night sky is golden.